Today's lesson is Module 5, Lesson 5, the area of polygons through composition and decomposition. Before we go any further, what's a polygon? What's a polygon? Right, a closed figure with straight sides, and it has to have 3 or more straight sides. And so we're going to look at all polygons, but we're going to use a technique called composition and decomposition, and I'll show why in a minute. Suppose we have a shape that looks like that. Okay? How many sides? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Anybody know what a 13-sided figure is? I don't know what a 13-sided figure is. If I don't even know the name of it, how am I going to figure out the formula for it? I don't know I know the formula for area of a parallelogram. What's the formula for a parallelogram? Area equals base times height. What about all triangles? It doesn't matter what kind of triangle it is. What's the area? 1/2 times base times height. Those are the formulas we know. And we can use those formulas to help us find the area of other polygons using this thing called composition and decomposition. So the base word compose from composition is a verb that means the act of joining or putting together. And that's what we looked at on the homework. You had that trapezoid. You found the area of the triangle, the area of the triangle, the area of the square, and then you added them all together. Decomposition means to take apart. So we're going to look at composition and decomposition to help us find the area of irregular figures. So we're going to look at those figures, break them up into triangles and parallelograms, and find the area. So the good news is, you know all this stuff already. You know how to do all this. So let's take a look at the opening exercise. Now, we have to be careful because on the opening exercise, we actually have 2 different tasks to do with the same picture. Okay, so we'll all do the first one together, and then we'll do the second one just using the picture on the board. No, I'm not going to give you like a vocabulary section on it, no. Yeah, well, that's what we're going to look at right now. We're going to look at that right now. So here's a picture of a wooded lot. In fact, my street, I live next to a big wooded lot, and we just found out they're building 4 houses, 2 on our side of the street and 2 behind them. So my husband was trying to look at the lot to figure out, because we found out how big the properties are, how big the houses are. So we're trying to figure out, well, how close to our property are they going to come? And my son wants to know, there's a field like over behind us, like this is our house, and there's a big field. Like, well, is my baseball field going to go away? Trying to figure out. So if we look at a big lot, let's try to see if we can figure out the area, because this is a 1, 2, 3, 4, 5, 6-sided figure. What do we call a 6-sided figure? Hexagon. And the formula for area of a hexagon is? I don't know. But real quick, what 2 shapes do we see there? What 2 shapes do you see? Yeah, I see 2 rectangles. Do we know how to find the area of a rectangle? Yeah. So let's label this with the measurements they gave us. If AB equals 10 units, so AB is 10 units, you can label this on your notes. FE equals 8 units. AF equals 6 units. And DE equals 7 units. But if I were going to break this up into 2 rectangles to find the area, I'm going to have a problem. So if this was my 1 rectangle, and if this was my other rectangle, well, do I know the length of DC? No. Do I know the length of the other side? BC? No. So right now, let's look at that, how we would find those missing links. So let's see if we can find the missing links. So DC, right here. We wanted to find DC. Well, I know that AB is 10. And I know that FE is 8. So if that part is 8 and the whole thing is 10, what is DC going to be? Whoops. I don't know what I just did. So what is this going to be? If this part is 8, the whole thing is 10, what's that going to be, everybody? 2, exactly. So now we know the measurement of that side. Now, what about BC? What about this side? Well, if I know that this part is 6, whoop, that part is 6. Okay, lost that. And if I know that this part is 7, what is the length of all of BC? Everybody? 13. Okay. Any questions on any of that? Where those numbers came from? So DC was 2 units and BC was 13 units. Now that I know the measurements of all the sides, I could go ahead and find the area. But we're not going to yet. Now they gave us another example, but the problem is in your notes, they didn't give you another picture. The picture at the bottom is not the picture that you need. So if you want to quickly draw this again, you can on the bottom of your notes. Cross out the picture that's there. If you want to draw this picture quickly, and then we could practice finding the measure of the missing sides one more time. So let's look at the information that they gave us. DC is 10 units. And FE is 30 units. AF is 28 units. BC is 54 units. So we have to find the lengths of the other sides. First of all, does anybody have any questions on how I labeled that picture? All I did was take the numbers out of the directions. So far, so good? All right. So how are we going to find AB? I think AB would be the easiest. Well, I'm going to look at what sides I have. I have 30 here, so I could slide that up. And I have 10 here. So what would be the length of AB? Everybody? 40. So AB is 40 units. This part you do have in your notes. The words you have in your notes. They just gave you the wrong picture. Okay? And DE. Well, let's see. If this whole side is 54, I'm sorry, DE. If this whole side is 54, this part is 28. So if that part is 28, we want to know what that is. So 28 plus what is going to give me my total of 54. So I'm going to have to do 54 minus 28. What am I going to get? 46, do we agree? That seems a little big. 26. Agree? 54 minus 28. So DE is 26 units. So now that we've practiced finding missing sides, now we can go ahead and look at finding area. But first, a question.
When you learn to do 54 minus 8, how many steps minus
Oh, that would make me so proud. Absolutely. That's why we learned all that. Absolutely. Somebody actually does listen to me. Okay. Let's take a look at example 1. Now, they didn't give you, I don't know who was working on this lesson when they made it. But I guess the teachers working on these lessons got tired because they didn't give you enough room to do the work. So I, being the wonderful teacher that I am, made a note sheet. So you should have taken the note sheet from the outbox, and you can put this in your binder, page 21 and 22. Oh, look at all the kids who didn't read the do now board. All right, so the intermediate school is producing a play that needs a special stage built. The diagram is shown below, not to scale, which means don't assume things are bigger or smaller or equivalent. On the first diagram, first of all, how many sides are there? 1, 2, 3, 4, 5, 6, 7, 8. So what kind of shape is that if it has 8 sides? Octagon, but it doesn't look like a stop sign. Could it still be an octagon still? Yes, it's an octagon. And the formula for area of an octagon is? I don't know. But what shapes do we see there? What shapes can we use? Yeah, we see lots of rectangles. So let's take a look. It says to divide the stage into 3 rectangles using 2 horizontal lines. Which way does horizontal go? Everybody show me. Which way is horizontal? Horizontal. So let's divide it. Here's 1 horizontal line. Let's 2 horizontal lines. So now I have shape A, shape B, and shape C. I'm going to change, these were numbered, but I think the numbers are confusing. So we're going to change them to A, B, and C. All right. What's the first step when finding area? Ladies, what's the first step when finding the area? Yes! Write the formula. Area equals base times height. So looking at shape A, what's my base? What's my base? 2. What's my height? Be careful. 5. Where'd you get 5 from? This whole thing is 9. This part is 4. So what is the height of A? The height is actually 4. So area is 8 meters squared. Now let's look at rectangle B. Area equals base times height. What is the area of the base and the height of shape B? Right here, shape B. What is the area, the base and the height of shape B?
7 is the base.
Very good.
And 5 is the height.
Nice. How did he get 5? This whole thing is 9, and this part is 4. 4 plus 5 will give me a total of 9. So the area of shape B is 35 meters squared. And what about shape C? What is my base and my height?
2 is the base and the height is 4.
Fabulous.
Area is 8 meters.
Perfect. Am I done? Do I know the area of the stage? The area is 8. No? Still not done? Ugh, now what? What do I have to do? Yes. Let's add our 3 areas together. So what is the total area? 51 meters squared. All right. Now, another way we could have looked at it is by drawing two vertical lines. So here's one vertical line. Here's another vertical line. So we have A, B, and C. So area is base times height. So what is the base and the height of shape A?
Base is 2 and the height is
Yep. So the area is 18 meters squared. What about shape B?
the base.
Ooh, what is the base? Well, let's see. That's 2. That's 2. And the total is 7. So what's this part going to be? If 2 plus what plus 2 equals 7?
The base is 3 millimeters.
3 meters. 3 meters. And what's the height? What's the height? 5. And rectangle C, what's my base and my height? Yep. So now I have to add my 3 areas together. Sure. Excellent question. I'm very happy that you asked that. Well, the whole height here is 9. I only need this part, right? So if this part is 4, what's left here? What's that part going to be? 4 plus what's going to give me a total of 9? So that's where the height came from, of 5. Good? That was a great question. Those are the types of questions you should be asking. Anybody else have a question where any of those numbers came from? All right. Let's take a look. Let's take a look at C. On the third, some people like horizontal, some people like vertical. Let's be fair and do one of each. Let's go crazy. So let's do, what's so fun? So let's do one horizontal and do one vertical. I still made 3 rectangles. Yes. You could have done it the other way. Yep, you could have done that. I mean, you could cut here and here, but you want to make as few shapes as possible. But yeah, you could have done this here and that here. You could have done it that way. But I'm going to go back to the way I had it. Okay. Okay. Formula. What is my base and height of shape A?
Base 2 and the height is 5. 4.
Rectangle B. What's the base of B? What's the yeah, what is the base of B? Nice. And what's the height of B? Nice. And rectangle C. The base and the height? Yeah. Let's add them all up. Oh my goodness, again we got the same answer. How can we keep getting 51 meters squared? That's crazy. They couldn't come up with different numbers? How could we get the same area over and over and over? How come?
Nobody ever divided different shapes, so it's the same overall shape.
The area didn't change. We still have the same amount of space. The original shape of the stage didn't change, so no matter what method we use, we're always going to get the same area.
Wouldn't it be called created?
Oh, well, in a sense, I guess that's sort of what we did. Not exactly, but you could look at it that way. What we did was deconstruct the picture or decompose it into separate sections and then found the area of the different sections. But did anybody see this when we first looked at it? Did anybody see it differently? Instead of seeing three smaller shapes,
If you want the gap on the top, just draw a line up.
you want to cut off the top. Here's your original shape. We're going back to our notes now, back to the original note page. So you want to cut off the top, and now we have this space that we don't need. So what we could do is find the area of the big rectangle and then take that area out. Does everybody see that? Let's take a look. So what are the dimensions of this large rectangle? What are the dimensions of the large outside rectangle? Dimensions meaning the measurements of the sides.
2, 4, 9.
Well, here, what's the base?
Oh, 7.
What's the height? Right. Very important to know dimensions. Oh, happy Memorial Day to my microwave. On Monday, my husband went to microwave something, and the whole thing went bananas. So my husband had to go buy a new microwave. But he had to make sure he knew the dimensions, so he didn't buy a microwave that was too big or too small and not fit, because it was one of those that goes above your stove in the cabinet. So you had to know your dimensions to make sure that it fits perfectly in the cabinet. So that's what dimensions are. Those are like your measurements. And if you go on Home Depot or Lowe's, it'll say DIMS, D-I-M. So if you want to buy furniture, you have to make sure that the DIMS of the couch or the TV console or the TV will fit in your living room. Okay? So anyway, so the dimensions of the larger rectangle was 9 by 7. Now what about that small rectangle that's inside? What are the dimensions of that smaller rectangle? Yeah. The large rectangle. What are the dimensions of this small rectangle in here?
It's not a question, but wouldn't 7 because that's...
Yeah, well, we're just looking at the dimensions. It's 9 by 7. Yeah, but you're right. Right, the smaller rectangle is 4 by 3. So let's find the areas. So for the large rectangle, the area is base times height. The area equals 7 times 9. The area is 63 meters squared. For the small rectangle, area is base times height. Area is 3 times 4. The area is 12 meters squared. Do I know the area of this stage yet? I know the area of the large rectangle, which is blue. The large rectangle. And I know the area of this, I know the area of the small rectangle, which is red. But do I know the area of the stage yet? The stage I'll shade in green. Here. Do I know the area of the stage yet? What do I have to do? What can I add them together? That's what we did with the other shapes. Do I add them all together?
Yeah.
So I'm going to take this and add that. No, I don't want the area of this. I have to take it out. So if I take it out, what am I doing? See if I can get it all out of there. No, I can't. Okay. Yes, I have to subtract. Sorry. So I need to subtract. So what is the difference? 63 minus 12 is... Oh, there it is again! Well, it's not units. We know that it's meters. So we keep getting the same area again and again. It didn't matter if we decomposed it or composed it. Yes. Yeah, Petros asked that already. We were just listing the dimensions. The dimensions are 9 by 7. But here we put the base is the base, the height is the height. Okay, so we were just listing the dimensions. Let's just take a peek real quick before the bell rings at example 2. We know that for a parallelogram, we can find the height by extending it and from a vertex down to a right angle. We know that. But the other thing we could do is if we drew a diagonal from A to C, what did I just form here? I formed a triangle. So could I find the area of that triangle and add it to the area of that triangle? Yes. Yes. Yes, I can do that. I can do that. The other thing that we could do, here's a trapezoid. I could cut that in half. Here's a triangle, and there's a triangle, and I could add the two areas together. Or what I could have done is boxed it out to make a rectangle, and then subtracted that triangle, and subtracted that triangle. So there's different strategies that you could use when trying to find the area of irregular shapes. You can deconstruct and add shapes together. Please don't pack up. You're making noise, you're distracting, and you should be writing this down. You should, in your notes, have drawn this, and you should, in your notes, have drawn that.